Now we're going to see exactly how to determine the number of valid hosts on each one of our subnets. And I'm going to show you exactly how to do this, and it is lightning fast. You will have no trouble with this on exam day or in the real world. We know now that our valid host questions, just as our valid subnets questions, can take more than one form because we have more than one way to express that mask. The questions, how many valid hosts are on the 200.10.10.0/26 subnet, and how many are on the 200.10.10.255.255.255.192 subnet, are exactly the same question. One's using prefix notation, the other's using dotted decimal, and we know we have to be ready for either one of those formats on our exams. Now, we need to know how many host bits this subnet has. That's where we're going to start with determining the number of valid hosts on a subnet. There is a lightning fast way to figure that out. 32 minus the number of ones at the beginning of the mask is equals your number of host bits. That's it. So when you're given the network 200.10.10.0/26, again, just like with the valid host questions, the subnetting's already been done. We're coming in after the fact and figuring out how many hosts we have on each one of our subnets. Well, for this, we need to know the number of host bits. And the only thing you've got to do to get that number is take 32 and subtract basically your subnet mask from that. We have 26 bits set in a /26 mask. That's where we get the 26 from. All we do is subtract 26 from 32. That gives us 6. We're almost done. Remember that gotcha I mentioned? It's very small, but here it is. We're almost done because you're going to raise 2 to the power of the number of host bits and then subtract 2. That's your number of valid host addresses. And with practice, you can figure this out for any subnet in well under a minute. Because all you got to do, again, this would be 32 minus 26. You got 6. And then it's 2, 4, 8, 16, 32, 64. Subtract 2, which I've bolded twice, and equals 62. A couple of things to watch out for here. Note that this formula uses the number of host bits, not the number of subnet bits. Makes sense. When we're concerned with the number of valid subnets, we're working with the network and the subnet bits. When we're trying to figure out how many, or are figuring out how many hosts we have, valid hosts, we're using the host bits. We subtract 2 from the almost final answer when it comes to the number of valid hosts. Why exactly do we do that? I don't want to just tell you that and then not say what the addresses are. And you're going to see these in questions later in this section of the course. But that -2 accounts for 2 unusable host addresses. The first address in the range of our subnets is the subnet number itself. We don't want to use that on a host. The last address in the range is the subnet's broadcast address. If you try to use either one of those addresses on a Cisco router interface, it's going to tell you, sorry, can't do that, or something, probably bad mask will be your message. And that's actually what it means, that you're trying to use one of these 2 addresses. Since we shouldn't use either one of these on a host, we need to subtract 2 when we're calculating the number of valid hosts in a subnet. But that's it. 32 minus the number of ones in the mask, and then you take that 2 to that power minus 2. You don't even have to write anything out if you don't want to. Give me a second here and I'll bring up some practice questions for us here. Here's a good one to get started with. 220.11.0, let me center it up a lot. 220.11.10.0/26. How do we approach that? Well, we're going to start with 32 minus 26 equals 6. Because they gave us the length of the mask. It's 26 ones. So we know that we have 6 host bits at the end of that address. So we have 6 host bits to work with. 2 to the 6th power, 2, 4, 8, 16, 32, 64, minus 2 equals 62. Now, I'm not saying I'm Nostradamus or even Criswell, but I will say that if I were writing a practice exam question and gave you that network, I guarantee you one of the choices I would put would be 64. And that's where you got to remember the -2 for the valid hosts, because you don't want to answer 64 to this. We're there to take exam points, not give them away. Let's take a look at another network. 129 1500/21. You don't even have to write anything down for that. You might want to write the powers out. But let's see what you've got. You got 32 minus 21 because they already gave it to us in prefix notation. So that means we have 11 host bits. So it's 2 to the 11th power minus 2. So that is, take a deep breath, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. Don't know if they'll ever go that high. Excuse me for that. It spun up on me. There we go. So that would be 2048, which is 2 to the 11th power, minus the 2. And there you have 2046. I don't know that Cisco will give you a mask where you've got to go to the 11th power, to the 10th power, but it's better to practice it and not have to use it than not having practiced it and have to use it. So again, that's all there is to figuring out how many valid hosts you have on each one of those subnets. Let's do another one here. You can do this one just by looking at it, I bet. Especially with that /30, because that's a very popular mask for point-to-point links. So if we do 32 minus 30, that leaves 2. I'm not even going to type that. And 2 squared, 2 to the second power is 4 minus the 2, and you end up with 2 valid host addresses on that subnet. Here's a /28. So what do we got? 32 minus 28 equals 4, 2 to the 4th power, 2, 4, 8, 16, minus 2, 14 valid host addresses. Uh-oh, got one we got to do a little bit extra calculating here. But what do we got there? How many bits, how many ones are in the mask 255, 255, 255, 192? If you had to express that in prefix notation, how would you do it? /26, right? Because we know that here's 8, there's another 8 for 16, there's another 8 for 24, and then you have the next 2 bits, the 128 and 64 bit, would be set to bring you to 192. So it's 8882/26. So that would be 32 minus 26 to get the number of host bits. And then 2 to the 6th power, 2, 4, 8, 16, 32, 64, minus 2, 62 valid addresses per subnet. We have another one here? Actually, we don't. But that's all there is to it. If they give it to you in prefix notation, they've done most of the work for you. We've seen that already, because we saw that with this particular example. You've got 32 minus 28 is 4, so you got 4 host bits, 2 to the 4th power, 2, 4, 8, 16 minus 2, 14, and you are all set. That's all there is to this one. So once you've got this skill down, it won't take you long with practice, and you're comfortable with calculating the number of valid subnets, go ahead and head to the next section, and we'll start putting these all together into even more real-world scenarios. I'll see you in the next video.